In this video, I will explain find the exponential Fourier series expansion of the Fourier rectified cosine function shown in figure. Find the exponential Fourier series expansion. Fourier series expansion of the full wave rectified cosine function shown in figure. This is the waveform. Sub t. Minus pi by 2, 3 pi by 2, minus 3 pi by 2, like that. This is the waveform. This one is t. First of all, I have to find out the time period of the waveform. Time period of the waveform is this is the time period of t0. Time period of the waveform. Suppose small t0 is equal to minus pi by 2. Small t0 plus capital T0 is equal to pi by 2. Small t0 is minus pi by 2 plus t0 is equal to pi by 2. Therefore, t0 is equal to pi by 2 plus pi by 2 is equal to pi. Time period of the waveform is pi. Next one is a fundamental equation. Find out the fundamental equation of the cosine function. This one is the fundamental equation. One cycle, consider one cycle. This one is A. This one is minus A. Pi by 2. Next one is this one is 3 pi by 2. 4 pi by 2. 4 pi by 2 is 2 pi. Therefore, time period of the waveform. This one is pi by 2. Here, 2 pi by 2. 2 pi by 2 is 5. 3 pi by 2. 4 pi by 2. Therefore, time period is 4 pi by 2 is 4 pi by 2. That is 2 pi. Time period of the waveform is 2 pi. Fundamental equation of the cosine function is x of t is equal to a cos omega t. That is equal to a cos omega is equal to 2 pi by t. That is equal to a cos 2 pi by t is 2 pi. That is equal to a cos t. This is the waveform. Exponential Fourier series of that any function, periodic function, x of t is given as sigma n is equal to minus infinity to plus infinity Cn e power j n omega naught t. Here the sigma n is equal to minus infinity to plus infinity Cn e power j n omega naught is 2 pi by t0 into t. That is equal to sigma n is equal to minus infinity to plus infinity. From that waveform, the time period is t0 is pi. Initially explained, the time period of the fully rectified cosine function is pi. Cn e power jn 2 pi by t0 is pi into t. That is equal to sigma n is equal to minus infinity plus infinity Cn e power j 2n t e power j 2n t. Find out that this is the exponential Fourier series extension. Find out Cn quotient, exponential Fourier series quotient Cn, and then plot the magnitude response of that function. 1 by t naught, t naught, t naught, small t naught plus capital T naught, x of t e power minus j n omega naught t dt. 1 by t naught. We know that time period of that waveform is 1 pi. That is 1 by pi. T naught is minus pi by 2 to plus pi by 2. That is here minus pi by 2 to plus pi by 2. X of t e power minus j n omega naught. Omega naught is 2 pi by t naught into t dt. That is equal to 1 by pi minus pi by 2 to plus pi by 2. X of t e power minus j n 2 pi by t naught is pi t dt. That is equal to 1 by pi minus pi by 2 to plus pi by 2. X of t e power minus j 2n t dt. 2n t dt. Here x of t is the fundamental equation. X of t is a cost. X of t is a cost to substitute 1 by pi integral of minus pi by 2 to plus pi by 2. X of t is a cost e power minus j 2n t dt. E power minus j 2n t dt. X of t. Find out the e power a cos t e power minus j 2n t dt. Here a by pi minus pi by 2 to pi by 2 e power minus j 2n t cos t dt. E power integral of e power ax by e power ax integral of e power ax cos bx dx is equal to e power ax by a square plus b square a cos bx plus b sin bx. This is the integration a by pi. Here a is equal to minus j 2n minus j 2n, b is equal to 1. 1 equal to b is equal to 1. E power minus j 2n t by minus j 2n whole square, b is 1 whole square, a is minus j 2n cos t minus j 2n cos t cos t and plus b is 1 into sin t minus pi by 2 to pi by 2. This is the here substitute a by pi into minus whole square, minus plus j square is minus 1, 4n squared, 1 minus 4n squared. Substitute pi by 2 e power minus j 2n t is pi by 2 minus a 2n cos pi by 2 sin pi by 2 minus lower integral minus e power minus a 2n minus pi by 2 minus a 2n cos of minus pi by 2 is cos pi by 2 plus sin of minus pi by 2 is minus sin pi by 2. Sin of pi by 2 is sin of minus pi by 2 is minus sin pi by 2. After substituting here, a by pi into 1 minus 4 n square. Here cos pi by 2 is 0. This value is 0. Cos pi by 2 is this value is 0. Sin pi by 2 is 1. Here the sin pi by 2 is 1. Minus into minus plus. Here e power minus a 2 cancel. E power minus a n pi. Here 1 is there. Here this value is 0 minus into minus plus e power 2 cancel e power minus a n pi. We know that cos x is equal to e power this one is plus minus into minus plus. Cos x is equal to e power jx plus e power minus jx by 2. Here 2 is not there. Numerator and the denominator is multiplied with 2. 2a by pi into 1 minus 4 n square. This is the Cn e power minus e power jn pi plus e power minus n by 2 is cos n pi. Cos n. Find out the values of where n is equal to 0, plus or minus 1, plus or minus 2, plus or minus 3, and so on. Let n is equal to 0. Therefore, C0 is equal to 2a by pi into 1 minus 4 into 0 whole square. 4 into 0 square, that means 0. Cos 0. Cos 0 is 1. That is 2a by pi. Mod C0 is also 2a by pi. N is equal to 1. N is equal to 1 means C1 2a by pi into 1 minus 4 into 1 square. Cos pi. That is equal to 2a by 1 minus 4 minus 3 pi. Cos pi is cos 90 plus 90 minus sin 90 minus sin 90. Minus cancel. Therefore, mod C1 is equal to 2a by 3 pi. And similarly, C minus 1 is equal to 2a by pi into 1 minus 4 minus 1 whole square. Cos of minus pi is cos pi. Therefore, C minus 1 value is also 2a into minus sin 90. Cos pi is minus sin 90 minus 3 pi again. Minus cancel. Therefore, C minus 1 is equal to 2a by 3 pi. Mod C minus 1 is also 2a by 3 pi. Now consider n is equal to 2. N is equal to 2. C2 is equal to 2a by pi into 1 minus 4 into 2 square into cos 2 pi. Cos 2 pi. 2 pi means 360 degrees. 2a by pi into 2 square 4 into 4 16. That is minus 15. Cos 2 pi is cos 180 plus 180 that is minus 2a by pi minus cos 180. That means 90 minus theta, 90 plus theta, 180 minus theta, 180 plus theta, all silver t. Therefore, cos of 180 plus 180 is minus cos 180. Minus cancel. 2a by pi 15. Again, cos phi is cos 180 is minus 1. Minus 2a by 15 pi. Means 2a by 15 pi. Mod C2 is equal to 2a by 15 pi. And similarly, C minus 2 is equal to 2a by pi into 1 minus 4 into minus 2 whole square cos 2 pi. Cos 2 pi. Cos 2 pi is 1. Cos 180 plus 180 minus sin 80. Sin 1 minus cos 180. Minus into minus plus. That is 1. 2a by pi into minus 15 cos 180 plus 180. That is equal to 2a by minus 15 pi. Cos of 180 is minus cos 180. That is equal to 2a by minus cancel. 2a by 15. Cos of 180 is minus sin 90. Minus 2a by 15 pi. Therefore, C minus mod 2 is equal to mod less. Here we use 2a by 15 pi. Therefore, C naught is equal to 2a by pi. C naught is equal to 2a by pi. Mod C1 is equal to mod C minus 1 is equal to 2a by 3 pi. 2a by 3 pi. C2 mod of C minus 2 is equal to 2a by 15 pi. By using this these values, you have to draw the magnitude function. This one is n mod Cn. For n is equal to 0, the value is 2a by pi. For n is equal to 1, 2a by 3 pi. N is equal to minus 1, 2a by 3 pi. N is equal to 2 and n is equal to minus 2. The value is 2a by 15 pi. 2a by 15 pi. This is the magnitude function of that exponential Fourier series. Next, determination of Fourier series coefficients from exponential Fourier series coefficient. We know that Cn is equal to an minus jbn by 2. C minus n is equal to an plus jbn by 2, where an, bn are the actual Fourier series coefficients. Cn, C minus 1 is the exponential Fourier series coefficients. We know that Cn is equal to 2a by pi into 1 minus 4 n square cos n pi. C minus n also, C minus n is equal to 2a by pi 1 minus 4, n is replaced with minus n whole square cos of minus n pi. Cos of minus n pi is cos n pi. 2a by pi into 1 minus n whole square is n square, that is cos n pi. Therefore, Cn is equal to C minus n. Cn is equal to 2Cn is equal to An minus JBn. 2C minus n is equal to An plus JBn. Add these two equations. 2C minus n is equal to An plus JBn. Add these two plus 2 into Cn plus C minus n 2 An. 2 cancel. Therefore, An is equal to Cn plus C minus n. But Cn is equal to C minus n. Therefore, Cn plus Cn, that is equal to 2Cn. The value of Cn is equal to 2 into 2a by pi 1 minus 4n square cos n pi. That is finally An is equal to 4a cos n pi into 1 minus 4n square. This is the one Fourier series question. Next one is Bn. To find out Bn, we know that 2Cn is equal to An minus Abn. 2C minus n is equal to An plus JBn. Minus, we use minus, subtract these two are cancelled. 2 into Cn minus C minus n, that is here minus sign, minus 2j Bn. These two are equal, therefore 2 into Cn minus Cn minus 2j Bn. 2 cancel, therefore Bn is equal to 0 by minus 2j, that is equal to 0. But next find out A0 is C0. We know that C0 value, we know that Cn is equal to 1 by T0 minus pi by 2 to plus pi by 2, that is T0 is pi. T0 is pi x of t e power minus j n omega naught t dt. For n is equal to 0 means that is n is equal to 0, C0 1 by pi minus pi by 2 to pi by 2 x of t e power n is equal to 0, e power 0 is 1 x of t dt. We know that x of t is equal to 1 by pi minus pi by 2 to plus pi by 2 a cos t dt. That is equal to a by pi. Integral of cos t is sin t. Sin t pi by 2 to minus pi by 2. That is equal to a by pi sin pi by 2 upper limit minus of sin minus pi by 2. That is a by pi sin pi by 2 sin of minus theta minus sin theta minus into minus plus sin pi by 2. Sin pi by 2 is 1, 1 plus 1 is 2, that is equal to 2a by pi. C0 or A0 is equal to 2a by pi. Here also in the C0 value is 2a by pi. With this the analysis is complete.